When Neil Armstrong set foot on the moon in 1969, 600 million people tuned in to watch. By 1972, enthusiasm had waned a little, but Apollo 16 carried a significant, if little celebrated first, a telescope to view the Earth and heavens from the lunar surface. The chance to put a telescope on the moon was a great opportunity for the young astronomer, George Carruthers. With this telescope, he confirmed that gas clouds between stars contain molecular hydrogen, as astronomers had expected, and took photos of the Earth in UV light, displaying the extent of our hydrogen atmosphere. The Apollo program was wound up later in 1972, and Carruthers' telescope has sat lonely on the Descartes Highlands ever since. But that didn't keep scientists from dreaming and scheming of using the moon as a base for observing the universe. Now exploring and exploiting the moon is back in fashion, and astronomers hope to seize this opportunity to turn the moon into a grand observatory. The lonely telescope may soon have some new friends. Radio astronomers are particularly eager to build a telescope there to peer back into the deep, dark past of the universe. For several hundred million years after the Big Bang had cooled, the universe was dark and featureless, filled with neutral hydrogen gas, but no stars. Within these clouds, very occasionally, a hydrogen atom would spontaneously emit a photon with a unique frequency of 1.4 gigahertz. That light is referred to as the 21 centimeter line, owing to its unique wavelength. The Earth's ionosphere blocks these faint signals from space, and terrestrial transmitters cause noisy interference. The lunar far side is the perfect place to detect these low-frequency signals, as it's shielded from interference from Earth, and the moon has no ionosphere. With an array of widely spaced antennas on the far side, astronomers could map the density of neutral hydrogen across space and time during that dark age, identifying the clumps of gas that would later form into galaxies. Teams of astronomers are planning experiments to see just how feasible this is, starting with moon-orbiting satellites with extending antennas designed to detect this dark age signal. Another plan could use autonomous rovers to lay out antennas made of conducting film in huge arrays to produce a lunar radio observatory. The rovers could be controlled by crew on board NASA's planned moon-orbiting space station. Although radio astronomy has a compelling case for a lunar observatory, optical and infrared telescopes on the moon would also be hugely valuable. Telescopes on Earth can be made very large to capture the faint light of distant objects, but they're always at the mercy of shifting fluctuations in the density of the atmosphere, the process that makes the stars twinkle. Modern telescopes can compensate for this effect to a degree with deformable mirrors, but telescopes in space are immune to the problem. This is why the Hubble telescope is able to peer further than any ground-based instrument, despite its relatively small mirror. The size of orbiting telescopes like Hubble is limited by the capacity of the rockets that launch them, but if a way could be made to make mirrors on the moon, it might be possible to build a telescope with clearer vision than Hubble. One approach that astronomers have been studying would be to create a mirror from a spinning liquid. This process seems straightforward. Take a large circular dish, fill it with the liquid, gently spin it, and centripetal force naturally creates the perfect parabolic shape for a mirror. On Earth, this has been done with liquid mercury, which is naturally reflective, but on the moon, mercury would evaporate. Instead, researchers believe that they could use a molten salt that won't evaporate, topped with a thin layer of reflective silver, less than 100 nanometers thick. In the moon's low gravity, the necessary support structure would be simple and cheap to build, and since the moon is seismically quiet, no tremors would disturb the spinning liquid. But building a 20-meter telescope on the moon, 10 times the width of Hubble, would still require transporting over 3 tons of materials from Earth, which doesn't come cheap. One solution to that problem is to use local materials. One team has made a small test mirror by mixing simulated moon dust with epoxy. If such telescopes could be constructed cheaply, then it would be possible to make arrays of telescopes and combine their light to achieve a resolution unimaginable on Earth, good enough to study the surface of planets around nearby stars. None of these plans have yet gotten the green light, but with private space agencies and companies planning expeditions in the near future, opportunities may soon arise. But renewed interest in the moon comes at a price. If companies begin activities, such as mining for minerals on the lunar surface, this pristine vantage point may be spoiled before astronomers even get a chance to use it.